Today, we're pulling back the curtain on something you use every single day, probably without even realizing it. We're talking about microservices, the invisible architecture that basically runs the modern internet. It's the secret sauce behind the biggest apps out there, and we're about to figure out how it all works. I mean, really stop and think about that for a second. How can a system that massive, with millions of us using it all at once, feel so seamless and constantly get new features without just collapsing? It seems kind of impossible, right? Well, that is the exact puzzle we are going to solve today. And the answer means leaving an old, tangled way of doing things behind. You see, for a long time, applications were built as what we call a monolith. And this image of a tangled ball of yarn is perfect. Imagine every single feature, your user profile, the payment system, the product recommendations, all twisted together into one giant, messy ball of code. If you try to pull on just one thread to change something, well, the whole thing could unravel. So let's break that down. On the left, you've got the monolith. Everything is tightly stuck together. A tiny bug in one small feature could literally bring down the entire system. And trying to scale it up for more users, it's an all-or-nothing nightmare. But on the right, you see microservices. It's a totally different philosophy. The application is broken down into small, independent pieces that can be managed separately. This is the core idea we're going to run with. Instead of that one tangled mess, think of a microservices application like a bustling city. Each building is its own separate, independent service with a very specific job to do. You've got the payments building over here, the user account skyscraper over there, and the shopping cart warehouse down the street. They're all separate, but they cooperate to make the whole city function. So here's the textbook definition. The really crucial part to get is that each service is its own mini application. It can be developed, deployed, and scaled up or down completely on its own, without affecting the others. And the way they talk to each other is through something called APIs. Think of these as the roads and telephone lines connecting all the buildings in our city. All right, now that we have the basic map, let's actually take a tour of this digital city. We're going to check out the most important landmarks, the critical infrastructure that allows all these independent services to work together so smoothly. You ready? Let's go. Our first stop is the main gate. Every single request from the outside world, whether it's from your phone app or your web browser, has to pass through this one single, heavily guarded entry point before it can get anywhere inside our city of services. In the tech world, we call this the API gateway. It fields all incoming requests and acts like a master traffic director, figuring out precisely which service or building that request needs to go to. It's the front door, the reception desk, and the security checkpoint all rolled into one powerful component. And this gatekeeper is busy. It has a ton of important jobs. It checks your ID to make sure you're allowed in. That's authentication. It gives you a map to the right building. That's routing. It does crowd control to prevent a stampede from overwhelming any one service. That's rate limiting. And it keeps a log of everyone coming and going. All this boring but essential work is handled right at the gate, so the individual services don't have to worry about it. Okay, next stop on our tour. So once you're inside the city, how do all these different services find each other? I mean, the addresses of these buildings can change all the time as new ones are built or old ones are torn down. You need a reliable, up-to-the-second map. You need a citywide GPS. This is what we call service discovery. The easiest way to think about it is as a dynamic, self-updating phone book for all the services. When a new service comes online, it just adds its current address to the book. When another service needs to talk to it, it just looks up the latest address. This is what makes the whole system so incredibly flexible and resilient to change. Now, what about rush hour? Let's say one of our buildings, maybe the product recommendation service, gets a sudden flood of visitors all at once. You need a way to manage that traffic so you don't get total gridlock. That's a job for the city's traffic police. And that is the job of a load balancer. When a request comes in for a really popular service, the load balancer doesn't send it to just one building. It intelligently directs it to one of the many identical copies of that service that are running. It spreads the work out, making sure no single one gets overwhelmed. This is what keeps everything feeling fast and responsive for you, the user. So how do these services actually talk to each other? Well, there are two main styles of communication. The first way is synchronous, which is like a telephone call. One service calls another and then just waits. It has to hang on the line for an immediate answer before it can do anything else. The second way is asynchronous, which is more like a postal service. One service just drops a message in a mailbox and then goes about its business, trusting that the message will get picked up and handled eventually. That postal method often makes the whole system way more resilient because services aren't stuck waiting around for each other. Now, Building a city of independent services is incredibly powerful. But, as you can probably guess, it also creates some brand new, unique challenges. Life in this distributed city isn't always a simple walk in the park. Let's dig into how this architecture deals with some of those tricky situations. So think about it. When you place an order on Amazon, that one single click has to talk to the inventory service, the payment service, and the shipping service. So what happens if the payment goes through just fine, but then the inventory service fails? You can't just leave things half done, right? That would be a mess. The solution is a really clever workflow called the Saga pattern. For a process like placing an order that has multiple steps, if any single step fails, the system automatically triggers actions to undo the previous successful steps. So in our example, if inventory fails after your card was charged, a compensating action is automatically kicked off to refund your payment. It keeps the data across the whole system consistent. All right, here's another challenge. In a big, interconnected city, what happens if one service starts having problems? It might slow down, causing a huge traffic jam that backs up and brings the entire city to a grinding halt. You need some kind of safety switch to prevent that. And that solution is called the circuit breaker pattern. It works just like the one in your house. Normally, the circuit is closed and requests are flowing just fine. But if it detects too many failures from a service, the circuit trips and goes into an open state, which immediately stops sending requests to that failing service. This prevents a cascading failure. After a little while, it goes to half open and sends just one test request to see if the service is healthy again. If it is, boom, the circuit closes and traffic flows like normal. So we've seen the what and the how. But now for the most important question, why? Why go through all this trouble to build such a complex system? Let's zoom out and look at the fundamental principles that make this whole approach so powerful. First, and maybe most importantly, is scalability. In our city analogy, if the shopping cart service gets slammed during a holiday sale, you don't need to rebuild the entire city to handle the traffic. Nope, you just build more identical copies of that one building. You can scale each part of your system independently, which is just incredibly efficient. Second is fault tolerance. Because all the services are independent, the failure of one doesn't have to crash the whole application. With patterns like the circuit breaker we just talked about, the city can gracefully handle one building being closed for repairs while the rest of the city keeps on running without a hitch. And finally, there's observability. Look, when your application is a complex, distributed city, you absolutely need great visibility into what's going on. This means having detailed logging, metrics, and tracing to see exactly how requests are flowing through the system, where the bottlenecks are, and what might be failing. It's like having a high-tech, citywide surveillance system that helps you understand and fix problems fast. And that brings us to our final thought. Microservices are undeniably powerful. They solve massive challenges of scale and speed for the biggest companies in the world. But they also bring a whole lot of complexity to the table. They might be the perfect blueprint for building a metropolis like Amazon or Netflix, but would you really use that same blueprint to build a small town or even just a single house? That's the critical question every developer and architect has to answer.